Okay, so we're doing chapter 9, problem 75. So we have a 55 kilogram woman and a 72 kilogram man standing 10 meters apart on frictionless ice, shown here. Part A says how far from the woman is the center of mass. Okay, so let's go take, that means we're going to take the woman's position as our origin here in the x direction. So we can find the x center of mass now. Well, if the woman's position is the origin, that's just 0, so the top is just 72 kilograms times 10 meters, the position of the man, over 72 kilograms plus 55 kilograms. And this gives a x component position of 5.7 meters. So that means this will roughly be the x center of mass of the system. So that's the answer to part A. Part B asks if each holds one end of a rope and the man pulls on the rope so that he moves 2.5 meters, how far from the woman will he now be? Okay, so since there is no external force on the man-woman system, that means we know the center of mass is going to be the same position. We know that needs to be true. But the woman's distance will no longer be 0 because now the man's distance has changed to 7.5. So we can set up an equation now where the x center of mass, or 5.7 meters, needs to equal the mass of the woman, 55 kilograms, times the woman's position, plus the mass of the man, 72 kilograms, and the man's position, like I said, is now, instead of 10 meters, it's at 7.5 meters, divided by the total mass, and that is 127 kilograms. Now this is an equation, and we can just solve for what x the position of the woman is now. So now the position of the woman becomes 5.7 times 127 minus 72 times 7.5 all over 55. If we plug that in, we get an answer of 3.72 meters. Sorry, this is 3.272 meters. Okay, so these are all relative to the old woman position, though. So the actual distance from the man from the woman is going to be the position of the man minus the position of the woman, so 7.5 minus 3.272. So they are actually now, instead of 10 meters apart, they're going to be roughly 4.2 meters apart. Okay, now part C. How far will the man have moved when he collides with the woman? Well, when the man collides with the woman, he will be at the original location of the center of mass. So what that means is F, or the position of the man final, is going to be 5.7 meters. And we need to take man final position minus man initial position, which was 10 meters. So this is 5.7 minus 10, and that's just 4.3 meters. That's how far he's moved from his original position.